Till now, till now we have discussed the carry flag, okay, carry flag and auxiliary carry flag, auxiliary carry flag. Okay, so this carry flag is set when the after execution of any instruction, if the result in the result, if the carry is generated, then the carry flag is set. If the carry is not generated, then carry flag is reset to 0. Similarly, auxiliary carry flag. Auxiliary carry flag means when a carry is generated from lower 4 bits to fifth position. Okay, lower 4 bits to fifth position. Then the auxiliary carry flag is set. Otherwise, the auxiliary carry flag is reset. Okay, next parity flag. Okay, parity flag. Parity flag means this flag is set. Okay, this flag is set when when a even number of ones, even number of ones are there. Okay, even number of ones are there in the lower 8 bit of results. Okay, lower 8 bits, lower 8 bits of result, lower 8 bits of a result. Okay, so for example, recently we have taken move, for example, move AL comma 15 hexa and move BL comma 23 hexa. For example, add AL comma BL. Okay, then what happens? 15 hexa. That means 0001 and 0101. Similarly, 2 3 0010 and 3 means 0011. Okay, now addition operation. This is one arithmetical and logical operation. Addition operation. Addition operation means what? 1 1. That means 0. This is 1. Carry 1. That means again 0. This is again 1. So 0. This is 1. So 1. Next 1. Next 1. 0 0. So this is the 8-bit result. In this 8-bit result, the number of ones are odd. The number of ones are 3. That means odd number of ones are there. Okay, odd number of ones are there. So because of that odd number of ones, the parity flag is reset. The parity flag is reset. In this case, the parity flag is reset. Okay. Likewise, the parity flag. Okay. Next flag is sign flag or zero flag. Zero flag. Zero flag when this flag is set or reset. That means when the microprocessor computes the arithmetical and logical instructions, for example, if the result is equal to 0, then the zero flag is set. Okay. If the result is a non-zero result, then zero flag is reset. Okay. For example, move AL comma 53 hexa, move AL comma 53 hexa, move BL comma 53 hexa, for example. Okay. Sub AL comma BL. Subtraction. Okay. So then what happens? So 53 minus 53. So 0 0. Sorry. 5 means 0101, 3 means 0011. Similarly, 0101, 0011. Then what happens? This is the subtraction. So minus operation. 1 minus 1, 1, 0, 0, 0, 0. All entire, all bits are 0. That means it is a 0 result. Okay, it is a 0 result. That means then the 0 flag is set to 1. If the result is a non-zero result, for example, here it is a 2 3 hexa. Okay, so 2 3 means this position is 1 3 0 0 1 0. Okay, 0 0. This is 1. This is 0. Then what happens? This is 0. All bits are 0. 1 minus 0. This is 1. And 0 minus 1. This is 1 0. And this is 0 1. Okay. Here, even number of ones are there. Even number of ones are there. But the result is a non-zero result. So for this non-zero result, the zero flag is reset to 0. Okay. That is zero flag, parity flag. Next, sign flag. Okay. Sign flag. What is the sign flag? Sign flag means the name itself indicates this flag is used for signed bit of operations. This flag is used for signed bit of operations. This flag is used for signed bit of operations. Signed bit of operations means signed and unsigned. Okay. For example, in case of signed bits, what happens? The in case of it is a 8-bit data, it is an 8-bit data. Then in this, the 7 bits indicates data. 7 bits indicates data, and MSB bit, last MSB bit indicates sign or polarity. It is a positive or negative. Okay. For example, one signed number, I am writing one signed number, 1 0 0 0 1 1 1 0. For example, okay, this is one number. It is an 8-bit number. Okay. Normally, in unsigned representation, suppose in unsigned representation, okay, unsigned representation, this what is this number? What is this number? This is 8 and this is E. Okay, this is 8E hexa. This number is 8 and this number is E. It is a 8E hexa. Okay, same number in signed representation. Same number in signed representation. Signed representation. Then what happens? I told you only 7 bits. This is 7 bits. This is 7 bits indicates the magnitude of that number. Last bit, 8th bit indicates the polarity sign. Okay. So then what is this 7 bits? It is a E. Okay. It is a E number, and this 1. 1 means in the signed bit operations, 1 indicates a negative number and 0 indicates a 1 indicates a negative number and 0 indicates a positive number. 0 indicates a positive number. That means this is a minus E. Okay. Minus E. E means what? 14. E means what? 14. Okay. 14. 14 means this is a minus 14 decimal. This is minus E hexadecimal. This is minus 14 decimal representation. That is the signed bit. This is the signed bit operations. Okay. Now what is the sign flag? Sign flag means it is used for signed bit operations when the result is having most significant bit is 1, then the sign flag is set. Okay. And in the result, suppose this is the result, if the most significant bit is equal to becomes a 0 for signed bit operations in the result, if the MSB bit is equal to 0, then the sign flag is reset. Okay, the sign flag is reset. This is about the sign flag. Okay, so we discuss carry flag, auxiliary carry flag, parity flag, zero flag, sign flag. Okay, next one is the overflow flag. Next one is the overflow flag. Okay. Overflow flag. Overflow flag is also used for signed bit operations. Overflow flag is also used for signed bit operations. So when the microprocessor performing the signed bit operations, if the result is large enough and it is not accommodated in the destination register, then the overflow flag is set. Okay. It is also used for it is also used for signed bit operations. It is also used for signed bit operations. It is also used for signed bit operations. So the result when the result is large enough large enough and it cannot be accommodated in the destination register. Okay, it cannot be accommodated in the destination register, then the overflow flag is set to 1. Okay, otherwise it is reset to 0, vice versa, reset to 0. That is about the overflow flag. So finally, carry flag, parity flag, zero flag, sign flag, um, auxiliary carry flag, overflow flag. These are the 6 status flags, because based on the result data, these registers, these flags are either set to 1 or 0. Okay. Next, next one is the control flags. Already I told you processor control flags. Okay. So what are those? That is direction flag. That is direction flag, interrupt flag. Okay. Interrupt flag. And next one is the trap flag. Next one is the trap flag. Okay. So now what is the direction flag, interrupt flag, and the trap flag? Okay. So direction flag means, suppose if the direction is equal to 1, direction flag is equal to 1. Here, these are the control flags. Control flags in the sense the user can set or reset. The user can set or reset these flags. Suppose if the user set the direction flag is equal to 1, then one type of operation can be performed. If the user make it as a direction flag is equal to 0, then another type of operation can be performed. So finally, these flags can be set or reset by the user. Okay. So direction flag means it is particularly used for the string operations. It is particularly used for the string operations. Already I told you for the string operations, we are using 2 segments, that is data segment and extra segment. Okay. And the data segment in string operations, for this data segment, the segment address, I mean offset address is available in the source index register. Okay. Similarly, for the extra segment, the offset address is available in the destination index register. Okay. Now, this direction flag is equal to 1, then this source index registers contents and destination index register contents are auto decremented are auto decremented. When the direction flag is equal to 1, when the direction flag is equal to 1, the SI source index register contents and destination index register contents are auto decremented. That means automatically they are decremented by 1 until the string operation is completed. Okay. Similarly, if the direction flag is equal to 0, okay, if the direction flag is equal to 0. Then what happens? Same, it is also used for string operation, and for string operation, data segment and extra segmentation can be used. And for the data segment, the offset address is available in source index register, and extra segment, the offset address is available in destination index register. But the direction flag is equal to 0, so that these two register contents are auto increment, auto incremented. Okay, auto incremented. So then what happens? Auto incremented. Then what happens? Auto incremented. So then auto incremented. So then until the string operation is performed. Until the string operation is performed. Okay, that is about the direction flag. Okay, next one is the trap flag, for example. Okay, next one is the trap flag or interrupt enable flag. Okay, let us finish the interrupt enable flag. Okay, interrupt enable flag. So this flag, so when the user, when the user, okay, when when the user, suppose if the interrupt enable flag is equal to 1, then the microprocessor can respond, the microprocessor can respond to interrupts. The microprocessor can respond to, give the response to interrupts, or it will accept the interrupt. Okay, if the interrupt enable flag is equal to 0, then microprocessor neglects the interrupt, neglects the interrupts. Okay, it cannot accept. Okay, this particularly later we can discuss in detail, but here interrupt enable flag is can be set or reset. If it is set condition, then microprocessor can respond to the interrupts. If it is in reset condition, then microprocessor neglects the interrupts, maskable interrupts. Okay, that is interrupt enable flag. Okay, next one is the trap flag. This is the last flag. Okay, next one is the trap flag. What is meant by the trap flag? Okay, what is meant by the trap flag? Trap flag. It is also processor control flag. The user can set or reset this flag. Suppose if the trap flag is equal to 1. Suppose if the trap flag is equal to 1, then what happens? The microprocessor is undergoes the single step execution process. The microprocessor undergoes the single step execution process. What is meant by the single step execution process? Okay, for example, these are the some just a set of instructions, for example. Okay, this is one set of instructions. Generally, microprocessor, after completing this instruction, it will go to the next instruction. After completing this instruction, it will go to the next instruction. So likewise, it executes the series of instructions sequentially. Okay, it executes the series of instructions sequentially. Okay, but here when the trap flag is equal to 0, the microprocessor undergoes the single step instructions. Single step execution process. Single step execution process means once the first instruction is completed, Once the first instruction is completed, then the microprocessor stops the execution. Okay, then microprocessor stops the execution, and then it verifies all the register contents, flag register contents, memory location contents, all these. If all are okay, then it goes to the next instruction. Okay. Again, after that, after completing the second instruction, again it stops the execution and it verifies the contents of various registers and memory locations. Okay. So likewise, for every instruction, the execution is temporarily stopped and it will verify. Okay. So that's why it is called as the single step execution. Whereas if the trap flag is equal to 0, whereas if the trap flag is equal to 0, then a normal execution is possible. Okay. So complete one after the other, the instructions can be executed. Okay. So this is about the flag register. So today we have discussed, today I explained totally 9 flags. Totally 9 flags. Okay, so carry flag, auxiliary carry flag, parity flag, zero flag, sign flag, power flow flag, direction flag, interrupt enable flag, and trap flag. Okay, so these are the totally 9 flags. Thank you.